I bought 4 replacement LED lamps for my car's signal indicators from an eBay seller. These devices weren't cheap. In this video, I take one apart and I determine what about their design means that they are destined to fail. When I got my car a few years ago, it came with these bulbs for the signal indicators. They're marked WY21W. Here are the specs. When new, they draw about 1.5 amps and produce about 280 lumens, though that will decrease as the bulb ages. In reality, it produces an awful lot of heat and not a lot of light. Purely for comparison purposes, I used an app on my phone to get the intensity in lux. From 1 foot away, I measured 518 lux. This lamp has been on for maybe a couple of minutes and it's almost too hot to touch. And that's because most of the energy going into it is ending up as heat. What I wanted was something to produce a lot more light for the same amount of energy. The logical solution was to find an LED lamp. I bought 2 different kinds of LED lamps. These and these. And this one was much brighter. First, let's look at the ones I didn't use. It's 0.27 amps, 12.6 volts, and using my app from about a foot away, about 413 lux. I chose not to use this LED lamp for 2 reasons. First, because it's not even as bright as the incandescent lamp. Second, because it uses so little current compared to the incandescent lamp that it confuses the flashing circuit in my car and causes it to flash very quickly. Some people refer to this problem as hyperflashing. There are a number of solutions, but I'd like to keep this as simple as possible. So if I can find a lamp that works, is bright, and doesn't hyperflash, that would make me very happy. I found these on eBay. They looked interesting. They ticked off all the boxes, and they were not inexpensive. When I got these, I was absolutely gobsmacked. These drew 1.96 amps. In fact, more than these. And to say that this was bright is an understatement. If I had to take a random guess, I would have said this was maybe 2,000 lumens. Much brighter than a 100-watt equivalent bulb. It was painfully bright. Since that time, all 4 of them have failed. They flicker, and I'll show you exactly what I mean. Here's an additional warning if you are susceptible to seizures. Don't watch this part. And while this is an unusual effect, it's not what I had in mind for my flashing indicators. I want to know why they failed, which means I'm going to have to take them apart. Using a vise, I crushed the glass envelope. Yes, it was glass, not plastic. I've straightened out the wires on the socket, and you can pull off the socket. Inside you'll see 4 diodes, an integrated circuit, and a number of other components. As a result of my manhandling it, one of the LEDs fell off. Having not taken apart this kind of bulb before, it's going to be trial and error, hopefully more trial than error. What we have are the LEDs applied to a sticky material, and almost like a tape, which I'm sure is a flexible printed circuit inside. And this material, this is metal. This is a heat sink for the whole thing. And it looks like that this is connected to the rest of this. Okay, I'm going to do a little bit off camera.
It's time for a tasty and refreshing snack.
We're back. Hope you enjoyed your snack.
It wraps around this metal heat sink. It's very sticky. And I don't think there's going to be great thermal conductivity through this tape, which I think is probably the root of the problem. I would love to trace through this circuit. I've been unable to find any listings on this chip, which is labeled 74DDC.
I know it's a regulator chip.
I just like to know what it's doing.
So I'm putting 12 volts in. Right now there's no load, and out is almost 12 volts. So it's not doing anything, it's just passing 12 volts. Let's put a load on it. With a 1 amp load, I'm getting about 9 volts out in that waveform. With a 2 amp load, the voltage has dropped to just below 8 volts. There's no question then that the regulator is working, but it's also getting very, very hot. Let's reverse engineer the power supply board. There's a full wave bridge rectifier, so you can plug the LED in either way. The output from the bridge feeds the LED array directly and also goes through a smoothing network of 3 capacitors and a resistor to feed VCC to the chip. No doubt there is a MOSFET between pins 4 and 5 inside the IC that switches the output, the negative, on and off rapidly, depending on the load that it sees. The 1 ohm resistor on pin 6 is probably a current sense resistor. Any energy from the collapsing field in the output choke would be permitted to go through the LEDs through that output diode. Now let's look at the LED array, how it's wired. After removing the adhesive tape underneath the LED array, I found these traces. The traces connect to power like this. And it would appear that the LEDs are connected across the power rails like this. Each group of 3 LEDs sees the entire voltage across the array, for a total of 42 groups of 3. If this is indeed true, then we would expect to see LEDs flickering in groups of 3. Let's check that out.
There are LEDs here which are not lighting at all. There are some which are lighting dimly, and some which look like they're going at full tilt.
I've turned out the room light and slowed down the video, and you can clearly see that the LEDs are lighting in groups of 3, if they're lighting at all. A group is 3 in series, and all the groups are parallel with one another. LEDs vary widely, but there's one thing that they have in common, and that is that they must be operated within a certain voltage range. Here are graphs showing the brightness and current as you increase the voltage with some typical LEDs. By increasing the forward voltage by only 170 millivolts, you double the current through the LED. A full half volt triples the current and triples the brightness. Without a place for the heat to go, the LEDs will soon destroy themselves. It's hard to say whether they were intentionally driven at a high current just so they would be brighter, or whether they roasted themselves because there was poor heat transfer to the heatsink. I suspect a combination of the two. In any case, with a failure rate of 4 out of 4, I would not recommend these LED lamps. They are more likely than not to fail and empty your pocket at the same time. I hope you found this video interesting and informative. If you did, please give this video a thumbs up and subscribe to Mr. Brown's Basement for more entertaining videos.